Welcome to our product launch. I'm so happy you could make it. Before we introduce our new product, I will tell you a little bit about ourselves. So at Bruker, we're committed to develop innovative, high-performance analytical instruments that are still easy to use. So in our elemental analysis business unit, we work with our industrial partners to develop elemental analysis instruments that are top of the line in hardware, software, and support. Our instruments you find globally, worldwide, in production facilities where accuracy, precision, and uptime are essential. Metals are a very important material in the engineering toolbox. Their properties adjusted by precisely and carefully controlling their alloy composition. A quintessential technique to measure elemental composition in metals is optical emission spectrometry, or OES. And Bruker already provides a broad range of instruments to analyze metals. But our portfolio, our lineup got larger. So let me introduce you to our newest instrument, the Q6 Newton. Follow me.
Wow, this was already an impressive video, right, Peter?
For an impressive product, I think, yes.
So I think now it's time to tell our audience a little bit more about this fancy product here. So first of all, was one question for you, quite simple, which puzzles me a little bit. Why 300 years of innovation?
I knew this question will come. The answer is quite easy. It took mankind 300 years to come to that point to develop such a system. And the story behind it, at that time, there was a famous scientist, you know him all, Sir Isaac Newton, the father of classical mechanics and gravitation. But what is not so well known is that he also put research and published research into the properties of light. And one breakthrough was the discovery that white or visible light can be differentiated into its constitutional wavelengths, into different colors. And that was the birth, you can say, of spectroscopy as a science, and enabled and paved the way for all further developments like quantum mechanics, including optical emission spectroscopy, of course. Yeah. And to honor this great scientist, we gave this a name, Q6 Newton.
Wow, makes a lot of sense. Now let's dive a little bit into technology. So when we start, we excite the sample somehow. So we need a source, we need an excitation. In the video I saw the words smart spark. Can you tell our audience a bit more about what that actually means?
Smart spark or the source generator or the plasma generator, as you call it, is, let's say, the engine of any spark spectrometer. We apply high energetic pre-sparking to prepare the sample surface. Here, if you have little inhomogeneities, you melt it, and then before you extricate it, and we extricate with a lower power, with a way lower power, and that improves precision. But the source is also smart in the way that it includes an internal safety guard.
Yes.
So that makes the operation of the system completely safe, even for unskilled or less experienced users.
Yeah. So in other words, smart is not just a marketing term. We really put some thought into the excitation of our sample to make the best use of the instrument, to get better, reliable data, but also to protect the users. Yeah,
Of
nice.
course, yeah.
So next, excitation typically comes detection. Detection, we call it high sense. What is high sense, and how is it better than previous generations?
High sense is, as a name induces, it's more sensitive, it's higher, more brilliant, it has a higher resolution, it's faster. In the end, what you get is you get a way better signal-to-noise ratio, and that is what matters, what counts. And that contributes also, or translates, into time of analysis. You can expose longer and measure longer, and then you get the same signal-to-noise, or you do it in half the time and end up with the same signal-to-noise ratio. That is the benefit of high-sense detection, and we are applying here latest state-of-the-art CMOS technology, uncoated with an unmatched really quantum efficiency, especially in the vacuum UV range.
Yes, so we really thought this through again. Detection makes the system only good when you really go from the beginning to the end here in the innovation process. Another point is that these systems are typically in harsh environments. So we're talking about metal production sites, metal plants, steel plants. So quite hot, dusty foundries, basically. Yeah. How do we make sure that we always protect the system is always working, and that we also get good results?
Yeah, we have to interpret the word reliability in a broader scope and context. So reliability for us does not only mean that the system withstands and operates harsh environments. For that, for example, we had this rock steady mechanism. So we have an active thermal stabilization and insulation integrated into the system that holds all components, isolate them, and achieves temperature constantness of the optics in a very few limit, 0.2 degrees C.
Wow, that's impressive.
So that's really stable. And that translates also into analytic stability over the long term. Because if your optic is drifting because of thermal expansion, your results will drift and the optic is defocused. So optics of this size needs precise temperature control. And with our insulation and the integrated flow path, we achieve this the most power efficient way.
Yeah, so state-of-the-art excitation, state-of-the-art detection, enhanced, improved system stability. Now comes argon, always an important topic, also for operational cost. Is there anything you want to say about the argon consumption, argon use?
Okay, we need some argon, that is unavoidable, but we use it the most efficient way. So we have two optical components here of course the window, the entrance windows to the two optics that are in the system that need to be protected, but they mix and add up to the total argon consumption here. So that is not in addition, that is what necessary to prevent any maintenance on this windows and downtime.
Okay.
So, but otherwise we are using the argon in the most efficient way, and we achieved, because of tightness improvement of the entire system and, for example, the UV optic that is needs to be purged, savings of about 20% for any,
that's already a lot,
any circumstances. But in our new Elemental Suite software that is able to drive this electronics, we have also included different power saving mechanisms and levels, hibernation levels. And if you use this, depending on your duty cycle, you can achieve another 20% saving compared to previous systems or to normal systems. So ideally, you can end up with up to 40%,
Up to 40%,
savings without compromising anything on the analytics.
Excellent. Well, these are already some really interesting features here. So I think with that, we switch over to the next session to learn more about this exciting new Q6 Newton instrument. Thank you.
Thank you.
Hello, everyone, and welcome to our release event for the Q6 Newton. We are so excited that you could join us today. And we're going to have some different guests, and it's just going to be a great discussion of this. Now, on the right side of your screen, you will see a few panels. There is one called the chat and another one called the question and answer. So what you could do is go ahead and if you have any questions that come up, just type them in the Q&A, and then we will get to those questions as soon as we can. So the first guest that we have that I'm excited to bring on stage is the product manager for the Q6 Newton, and that is Peter Poplowski. Welcome, Peter.
Hello, John. Hello, everybody.
So we are so excited. I mean, the video, just absolutely amazing in terms of introducing this product.
And it's an amazing product. Not only the video is amazing, the product as well. We are all
right.
very excited about it.
So, we might have some people joining us who aren't so familiar with the technology. So here we're talking about elemental analysis, and that means basically identifying what elements are present. What kind of person do we typically see who's interested in an OES instrument?
Various people. If we think about metal manufacturing or foundry, we have, of course, the lab managers, everybody that's involved in quality control, foundry engineers. But when it comes then to more to the value chain where the metal is used, and where products are built out of the metal, then we talk about the automotive industry, mechanical engineering, aviation, all kinds of this, even construction areas. The world is made still out of metals, and so there's a need also for the QC and for the grade control of these materials.
So anytime you need that strength, that durability, that reliability, you're going to metal and the go-to analytical technique, OES.
Yes, first it is used and necessary for the production steps, to ensure that you produce the right quality with the right chemical composition. And in the end, if you get something from a supplier and if you are a manufacturer of goods, you need to ensure that you receive the right material. So easy.
All right. So now I guess the next question that people might have is, why Bruker? Why would Bruker be the right partner? Or, for example, this Q6 Newton from Bruker, what makes Bruker special in terms of that OES area?
Yeah, we have a huge experience on it. So not 300 years, but 30 years we have already with a broad portfolio on this. But what is even equal important is the service and support level that Bruker as a worldwide company can supply to our customers.
Yeah, and when you're talking about that reliability, like you said, you are manufacturing, you're putting out these metal parts, having that support structure is key.
Yeah, normally it shall not happen, and that product is very reliable and can operate 24/7, but you never know. In case of that you have a problem, you might have to trust that the manufacturer, the supplier, the partner can provide the service in time, because otherwise, without the QC, you cannot really operate and drive your business.
So now to dive a little bit into this product, so the Q6 Newton, like I said, great video, and also your interview there was really enlightening in terms of understanding some of the features. Now, what makes this instrument different than the other instruments in our OES family?
Yeah, well, that has also to do with the features, of course, but what the benefit is, or the first experience when you work with a system is, wow, this is fast. And to give you an example, we are able to do the full chemical analysis of a low alloy steel in below 20 seconds. So with the complete element set, and without any compromises in precision or accuracy. And that is really, really fast. And if that is not fast enough for lower laws, we have also so-called fast method that saves further 3 seconds, 3 to 4. Then that finishes the analysis in below 17 seconds. And that brings us really into the range of the big floor standing systems, or even on top of them. So speed is, without question, one of the primary properties of the Q6 Newton. Speed can only be speed with uncompromised data quality can only be achieved with this high sense detection system, of course, because speed and sensitivity are two, and signal to noise are two twins, yeah, but they don't get together. You have either that or the other, but here we have both, and that's the difficulty to get both and not be fast with a poor signal to noise, but we are fast and sensitive the same way, the same time.
Awesome. So now we do have a few questions that did come in. So the first one is the Q6 Newton software ready for Industrial 4.0 and integrating LIMS? Of course, right? That is one of the biggest important things is data tracking these days. So Industry 4.0 and LIMS.
I have to say yes, but I have to also say, okay, that is not specific to the Q6 Newton, because our software, which we call Elemental Suite, drives all our OS systems. And yes, it is prepared for Industry 4.0 and LIMS integration or L2 system integration. It's also automatable. So we have the AXS-COM interface, remote control interface. The systems can be integrated, especially the Q8 Magellan, the big system in automation. But we have various export formats for integrating results, exporting them to LIMS systems or to other systems. We can also write directly into a Microsoft SQL database somewhere on the net, for example, on the network. So, yeah.
So a lot of versatility, adaptability, and really important is just that ability to interface with anybody's data management systems, really. All right, next question that came in. It sounds as you have a real nice factory calibration on your Spark instrument. Is it possible to include any standards for those curves?
Yeah, it is. So yes, we have factory calibrations, and these are built on our huge CRM library that we have when developing the master calibration for systems. But Elemental Suite is flexible, of course, and that is a very common question or a common request here. I have a CRM that was not in your library, but I want to have it in the calibration curve, onto the calibration curve. And yet that's not trivial, but it's relatively easy, and it's so easy that we have, for example, a video that is showing this, and you can have a look, or even the end customers can have a look if they go to brukersupport.com, our support platform, and there are different videos about certain topics in Elemental Suite, and one video is dedicated about how to include your own samples onto the calibration curve.
Yeah, and that right there, that's again one of those most important points when it comes to any tool, is to have the people to back it up. And with Bruker and our heritage of support and the global footprint, no matter where you are, we will always have support. So we have that in the form of our service department, who will come, install the instrument, make sure it's all running. We have application group, who we're going to talk to a little bit later, who can help you with that. And we have a whole chain of people. So that's a great benefit of going with a company like Bruker. Now, do you offer any optional quick check programs? How fast are those? Do you get all the elements? Do you just get a subset?
Say again, I didn't got it acoustically. Additional what program?
Like a quick check. Yeah. So do you have anything where you can just do a quick check program?
Yeah, that is what I meant, or what I already indicated, that for lower noise we have the additional fast method that is suitable for samples that need less sample preparation, so less high energetic pre-sparking and homogenization in the beginning of the measurement. But it delivers, in contrast to some other systems on the market, it delivers you the results for the entire element set with uncompromised precision.
All right, great. And here's a very specific question. Can the Q6 Newton measure oxygen in steel?
Yes, it can. It's our first benchtop OES system that can really measure oxygen in steel. And we achieve detection limits something around 60 ppm for oxygen in that material.
All right. And then we had one more question come in, must be one of our current users, because they are asking, with this new release of the Q6 Newton, is the Q8 Magellan still going to be around?
It is, and it still represents our high-end system, because there's one feature in the detectors that cannot be handled by linear array sensors on solid state base, and that is time resolved spectroscopy. And for special applications, or to really achieve the highest, lowest limit of detection, you need time resolvement or gating of the sparks results, and that you cannot do with neither CMOS, nor with CCD, nor with any other solid state linear array sensor, because the speed of the electrons inside the wafer material, inside the silicon, is too low. So you achieve this speed only with the PMT sensors that we use in the Q8 Magellan. So without doubt, yes, the Magellan will still be there and represent our top instrument for the OES product line. Yeah.
All right, great. All right, well, thanks for the discussion. We are now going to move on to the next part of our release event here, and we are going to actually pull away the curtain, take a look at some of the engineering that actually goes into the Q6.
Hello everybody, I'm Michael from R&D, and today I'm going to present to you the Q6 Newton from an engineering perspective. Well, if you start a new development project, you of course always begin from your current lineup. In case of the OES, that gives us a really strong and solid base, and naturally the question arises, will the new system be an evolution or a revolution? Before I give you my personal take on that, I will first show you what we accomplished as a team. For the Q6 Newton, everything really starts with the development of the new high-sense platform electronics. This we specifically designed to maximize the benefits of our new CMOS sensors. In combination with our high speed and low noise readout electronics, these CMOS sensors offer a magnificent signal-to-noise ratio and a wide dynamic range. And let me give you here just a glimpse into the development process. If you do new electronics and new sensors, what that does is it really lengthens the time in the development until you have your first working prototype. So we had quite some time without gathering like real data from the system. So in the development teams, the tension was slowly rising, you know, did you always go down the right path or not? And so we were really excited when we for the first time pressed the button, and the results couldn't have been better. I mean, right from the beginning, very clean, low noise spectra. It was really a moment you live for as a developer. Today, our systems are obviously much more sophisticated, resulting in outstanding LODs, significantly shorter measurement times, while maintaining excellent precision and accuracy. In the engine compartment of the Q6 Newton, we use our well-proven multivision optical concept. Comprised of two optics ranging from the vacuum ultraviolet to the visible range, this uses a total of 10 of our new high sense detectors. Here, the challenge we faced was how to improve on an already excellent system. And I want to give you just a few examples of this. First, we decided on using a coating-free CMOS sensor for the vacuum ultraviolet range, meaning everything between the oxygen and the nitrogen line, thereby opening up this area for our analytical program. Second, we looked at the optics geometry and alignment, and where we saw advantages in reach, we realized them. A good example of that is the antimony line at around 260 nanometers, commonly used in the aluminum base. And third, we simultaneously improved the thermal stability of our optics and used our new rock static concept. This offers you superior thermal management by embedding the optics and the whole system really into a packaging like foam material. And what this does, it gives you really nice opportunities of three-dimensionally shaping the airflow through the system, and other things like mounting subcomponents or even electronic boards without the use of screws, just in that foam material. And all of this results in basically in two things: a very good insulation from the outside and a very good temperature stabilization. Apart from these more technical aspects, we of course also took steps to improve the user experience. And first I want to mention here is the new machine control software, which offers ultra-stable and interference-resistant communication between the client PC and the system. And it does that while maintaining the Elemental Suite user interface you are all used to. This is complemented by superior diagnosis functions, which allow for fast and reliable help in case any challenges should occur to the customers. In the same spirit, we simplified service, such that the device doesn't have to be opened for normal service work. With that, let me come to the beginning and my question of whether this is an evolution or a revolution. Well, on the one hand, we did change quite significantly all the things on the inside of the system. But it still behaves like our well-known OES products. For that reason, I don't see it as a revolution. On the other hand, our fantastic development team in both Malaysia and Germany did a lot of great stuff. The device has a new brain with the new electronics. It has new eyes with the new sensors and a lot of little changes I don't have time for. For that reason, I don't see it as a mere evolution, but more of an evolutionary leap.
All right, so there we go, a little look behind the curtain, and to kind of evaluate or talk about that more, we have actually Michael Shurika here.
Hello, John. Thank you for the introduction.
So Michael, I mean, it sounds like this was a really exciting product to work on. What was your favorite part of the process in terms of designing this new instrument?
Oh, it's a good question, actually. There were quite a lot of them, actually. One, what was really exciting and really like a new thing to do was, using this foam-like material to really, like, you do not often have the shape to You do not often have the possibility to three-dimensionally really do structures in material and to nicely guide the airflow all around the spectrometer. So that was possibly one of the most fun one, also for the whole development team, because really we had a lot of discussions and we tried out also a lot of things, got some outside help from people who are experienced with that. And that was for sure one of the most fun things during the development process.
Yeah, and the whole system, the thermal management. I mean, I can only imagine how important this is. I mean, you can be sitting there on a pour floor by the foundry. You got huge temperature variations depending on what's going on, and so this system really helps out with that situation, right?
Yes, it does. It does. Because first, it gives you this very good thermal insulation. Basically, it allows you to completely seal off your whole optical setup from the electronics part. And then, of course, we did some steps to ensure the thermal stability of all of that. One is that our power consumption in the actually stabilized region is very low. Since we have this very good insulation, we don't get anything from the electronics or from the outside, or not much at least. And that allows us basically to very, very precisely stabilize everything. And what that does is, the more stable your system is, the more stable your results are. And this is what ultimately is important for the customer. And that we really achieved with this concept.
Is there any other part of the instrument that you feel was, you had said kind of this leap forward, where you think it's very important that we made that leap?
Yeah. Well, the other thing, what is really significant is the development of new platform electronics and making the CMOS sensor available as an option in OES. As Peter already said, all the CCDs and PMTs, they have of course, they're also good, but one thing what we see is, in particular with the line detectors, so future developments we assume are mainly in the CMOS area, and that's why that was really important to make our OES products ready for CMOS.
So what differentiates then that CMOS from the traditional detector? Is it that it's giving you a better signal to background or faster signal?
Yeah, I mean, here in particular, I mean, the electronics was specifically designed for that sensor. So of course we take, like the maximum possible benefits out of the CMOS sensor. And what it really does have is an amazing signal to noise ratio and a wide dynamic range. Okay, they are a bit linked together in the end, but this is really nice. And this gives you low limits of detection, as I said in my talk, and of course, shorter measurement times. Of course, you have to weigh a bit between the two. You cannot have the shortest possible measurement time and the highest precision, but I think we really found a sweet spot.
All right, great. And we do have one more question that had come in before. How many detectors do you have in the optics, and is it in vacuum or is it argon purged?
So in total, we have 10 detectors. 2 are under vacuum atmosphere. 2 are under vacuum atmosphere in the UV spectrometer, and 8 more are in the S spectrometer.
All right. All right. Well, thank you, Michael, for those insights into the actual development of the product. Oftentimes we don't get that, so thank you for joining us here. And now we are going to shift over and we are going to see some information from our applications group.
Rapid, reliable, and always ready. These are the words we use to define the Q6 Newton. And today, we are thrilled to share the state-of-the-art optical emission spectrometer with you. Our development team put a lot of effort into developing the Q6 Newton, which resulted in a powerful yet reliable instrument that exceeds the industry standards and provides accurate and efficient elemental analysis. My colleagues have already discussed various features of the system and explained the development process of this magnificent optical emission spectrometer. But, as the renowned physicist Carl Sagan once said, extraordinary claims require extraordinary evidence. So without any further ado, let's analyze some samples and have a closer look at the performance of the Q6 Newton. So here on the Sparks template, I have an ultra low carbon sample. I will press the green button to start the analysis. Here we will see how fast the Q6 Newton analyzes a sample. And again, this is thanks to high sense detection technology and all the new electronics that we have implemented inside. And for the level eye, we have a specialized method with which you can analyze a level eye sample under 20 seconds, as you have just seen here. So I will remove the sample and clean the tip of the electrode, rotate it, place it again, and start the second analysis. So these new electronics allow us to acquire, transmit, and process the data at a much faster rate, while the Smart Spark technology provides the optimum excitation parameters and creates the plasma. Now we have the second analysis done. Let's clean the electrode, rotate the sample a little bit, and start the third measurement. And of course, during the analysis, our argon shield technology ensures a stable plasma and also protects both UV and the fiber optic windows from the metal dust. This is thanks to its intelligent argon flow design under the Sparks template. Now the third measurement has just finished and we see all three measurements on the screen, so you can see the excellent precision of the system and repeatability. So I will continue with a cast iron sample. So I will remove the sample, clean the tip of the electrode, and position the sample here and start the analysis. Now we have seen how fast the Q6 Newton can actually be. However, it's not only fast but also reliable, and this reliability also means short-term and long-term thermal stability. This is where our rock-steady design comes into play. Rock-steady technology rapidly increases or decreases the system's internal temperature to the optimum level and ensures that it stays at that level. This thermal stability, of course, translates into the analytical stability as well. Now we have the first measurement. Let's go for the second one. When we designed the Q6 Newton, we also considered our current users. We wanted them to be able to use their existing sample adapters with the all-new Q6 Newton. This means that if you have a thin wire adapter or a thick wire adapter or a small sample adapter or a metal sheet adapter, you can analyze your samples using all these sample adapters with the Q6 Newton as well. So the second measurement is done. Let's go for the third one. Besides improving the Q6 Newton's analytical performance, we also thought about how to make an operator's daily analysis routine easier. With this in mind, we developed this multi-purpose button that you see on the system. So it not only starts and stops the analysis, but also communicates with you to give you information about the system's actual status. Steady green means ready to analyze, and it turns steady red during the analysis, as you see here. And if it's steady blue color, it's flashing the UV optics. If it's white, it means that the elemental switch is not connected at that moment. It will turn yellow, for example, when it's in the service mode, when you clean the Sparks template. If it's blinking red, which means that there's an error, for example, this might be caused by the low argon pressure in the argon bottle. So even if you're not working on the system and you are on the far side of the laboratory, this Q6 Newton will be still communicating with you from afar. So we have finished analyzing the cast iron sample, and you can see the results on the screen, and you witnessed the excellent precision of the Q6 Newton. And of course, the smart buttons functionalities are not limited to communication. If you need to lower the sample clamp without starting the analysis to position your oddly shaped samples, for example, all you have to do is to press this button just a little longer, And the moment you release the button, the clamp will go down, but it will not start the analysis. So to lift it up, you have to do the same thing. And you can also use the smart button to flash your UV optics, and this is done by pressing this button more than 5 seconds, and it will automatically start flashing the UV optics without the need of an external PC. So this was the first look at the Q6 Newton in a nutshell. Now it's time to go to the Q&A session, and I will see you there.
All right, so now we are going to be joined by Okan himself there in
Hey, John.
hello. So I see the instrument there right behind you.
Yep, it's right over here.
And that button that you were concentrating a lot on really makes that user experience quite fulfilling.
Yeah, it does. Actually, I can tell you a real life story about this. It was, I think, a few weeks ago or months ago, I don't remember. But when we had a long vacations or the holidays, we had the bridge weekend. So, and of course, there was nobody here in the laboratory, right? So after the vacations, I came to the office, I entered the laboratory, put my laptop here. I was going to check my emails. Then I saw that this light was blinking red. So I went to the system and checked that. And at that moment, I saw that the argon pressure was low because during the long vacation day, there was nobody, no maintenance people here. So the argon bottle was empty. And I was supposed to analyze a few samples that day later in the afternoon. So I called the guys, they changed the argon bottle. So I was able to analyze my sample that very same day. So when I said that the system can actually communicate with you from afar, it's really a benefit. So you can see what's going on with the system, even if you're not working on the system.
So in terms of actually, living with the system, using the system on a daily basis, how would you say, how would you rate that compared to some of the other OES type instruments that you've used in the past?
So I work for applications, right? So I use all the systems that we have in our OES product portfolio. And what I see, or I noticed immediately, was the speed and the limits of detection. So it was the first slide, we run some samples, low noise samples, and we could see the excellent limits of detection. And also, not only the limits of detection, but also the stability at that very low concentration level. That was amazing. So that was one of the things that surprised me the most, and also the speed of the system. So it collects the data quite fast, processes the data, and turns them into results at a much faster rate. And like Peter said, we also have this special fast method for the low alloy samples, low alloy steel samples, with which you can analyze samples below 20 seconds. So basically, what impressed me the most is the limits of detection and the stability of the results, so the precision, and also the speed of the system.
So now, in terms of users out there, we generally find that there's two types. One type is going to be someone who already has experience with OES, and then they're replacing their current machine. The other one is completely new. What would you say from an application perspective? How long does it take for somebody to, say, get up to speed once they have that instrument? How long does it take you to, say, train them so that they can really be using this tool effectively in their lab?
All right. So so mostly, I mean, for most of the system, it's actually the time it takes to train an operator is usually, I would say, one. Maybe with the Q8 Magellan, it might take a little longer, maybe 2 days. But what makes it easier is actually not only the system itself, but also our user-friendly elemental analysis software. So it's, I would say, the best the analysis software, OES analysis software in the market at the moment. And we also get these feedback from our customers who previously used some other systems from competitors. And the first day they operate the system with the Elemental Suite, they immediately give us feedback and say that it's so easy to use and it's so user-friendly.
So now, what about somebody who already has an OES solution? What do you find in terms of similarity? I guess you had mentioned the Elemental Suite. Is that common from all Bruker instruments?
Okay, so for the inside the OES product portfolio, we use one single software, the Elemental Suite, for all of our systems. And okay, so you asked me about the somebody who already has experience, right? So
Yeah.
for somebody who has experience, I mean, in the analysis procedure, there's not much difference because the sample preparation is the same depending on what kind of sample you analyze, either soft matrix or hard matrix. You either mill your sample or you grind your sample. So on the sample prep side, there's no difference. And on the analytical procedure side, pretty much all the OES systems work the same way. So you place your sample on the Spark stand and you start the analysis, okay? And then the real magic happens after you press the button. So how fast the data is collected and turned into to results.
So then in terms of the training, you do offer a service where someone like yourself can go on site and then do hands-on. Do you also offer any digital training?
Yeah, we also do that. I mean, actually, this started especially with the COVID a few years ago. So we started offering these online trainings as well, and it has worked out pretty well. So when on-site training is required, we do that as well. But if it's also okay for the customers, we do this online training, and it works quite well. All we need is we either do it on our system and show them how to use the software and the system, or the better solution is that we connect remotely to their system and show them how to use their system, and we analyze their samples in real time together. And this is how we train our customers.
All right. So we do have some questions that came in. The first one, how long would one measurement of a cast iron sample take? How about calibration?
All right. So in your presentation, actually, in the video that we have watched, there was a cast iron sample, and it takes approximately 30 seconds to run one cast iron sample. And about the calibration, actually, Peter also tapped into that. But so all the OES systems that we provide, they come with pre-existing calibration curves to cover all the common alloys in all the common matrices, right? And cast iron as well. So we have our calibration curves divided into different calibration or concentration ranges. But of course, you can always customize these calibration curves. You can put your own samples in the calibration curves. You can take some things out, and yeah, you can customize them in any way you want.
All right, great. Next one is sample preparation important for the Q6 Newton?
Yes, it is. Actually, I mean, regardless of the system that you are using, actually, even regardless of the analytical technique that you use, sample prep is always important, because your results can only be as good as your sample prep, right? So this applies to optical emission spectroscopy or XRF or combustion gas analysis, even XRD. You know that very well.
Yep.
So the sample prep is important. So as long as your sample prep is good, you can expect good results if your system is in a good shape. But specifically for the OES, in must is that your sample surface should be flat. Okay, that's a must for the OES sample analysis.
So is it sufficient just to say cut it off with a saw, or should we also be polishing it metallographically? I mean, what's your recommendation? It doesn't have to be shiny, but it should be smooth. Something in there.
Yeah, I mean, it should be flat, but it doesn't have to be shiny. And I mean, definitely not as shiny as some XRF samples, right? So we don't polish the sample surface. Actually, we just grind it. And we usually use for the hard matrices either 40, 60, in some cases 80 grade sandpapers. But we still need a certain level of surface roughness for the OES analysis. It should not be a mirror-like surface.
All right. So last question. How is the precision of the instrument for measuring carbon and sulfur?
All right, so carbon and sulfur. Okay, okay, maybe before answering that, we should talk about what affects the precision. Okay, if we put the effects of the sample itself, like let's say carbon and sulfur distribution inside the matrix, if it's inhomogeneous, and of course you can expect more variation in the results. If the sample is okay, and if your system is working also okay, then basically the precision level depends on the concentration level. Okay, for low concentrations, you should expect low precision, low standard deviation, high precision. For higher concentration levels, of course, you expect higher standard deviation. But at the end of the day, it depends on the concentration level. One of the samples that I have just analyzed in the video was ultra low alloy carbon steel. So I think it has something around 20 ppm carbon, but also around 20 ppm of sulfur. And if I remember correctly, the precision was around 1 ppm. Yeah.
So now there's a lot of numbers here. There's a lot of, making sure things work for a certain, sample and type and things like that.
Yeah.
What does the process look like if somebody would be interested in, say, looking at one of these instruments? How do they go about, contacting and then measuring samples, things like that?
I mean, on a daily routine, analysis routine?
You say somebody wants to send in a sample.
Oh, okay, sending a sample. Also, what they should do, of course, maybe they should get in touch with their local distributor, maybe the Bruker office directly in their region. And then what we do is that we send a sample submission form to them. They fill out the form and they ship the samples together with that form. And then we analyze their samples. And after that, we can either send the results or we set up a meeting and to go over the results together with them. If they want more explanation, we do that during that meeting. And we also can analyze their sample in real time in that meeting as well. This is basically how the process works.
All right, great. So you would set up kind of a call like this, and then
yep.
They would just be able to see you actually press the button.
Yeah, and the results appear on the screen. Yeah, you see everything in real time together.
Great. Yeah, and if anybody is interested out there, you can check out our website. The Q6 Newton is actually already available. So you just go up there under Products, Elemental Analysis, under OES, and you'll find the Q6 Newton. There's a link there for requesting the brochure, or if you are interested in something, go ahead and submit that interest there on the website. Now, to wrap up, I'm actually going to bring everybody back on here to stage. So we have Peter, we have Michael, and also we'll now be joined by Eckhart live. So welcome, everybody.
Hello.
Hi.
So we're really, this is really exciting to see a product actually come to life, to see it kind of for the first time going out to our customers. So what do we all think about the release? What do we think about the product in the end? Are we excited?
I am excited. As a day-to-day OES user, I am excited. Yeah.
All right.
Me
and
too,
we are
of
ready
course.
to measure those samples, right? If we were just talking about that actually with Okan. So if somebody is interested in sending something in, we do have instruments. I see one there.
Yeah, one here, one over there.
Yeah.
All right.
I'm very curious to get the first customer feedback, because we are very curious if they will share our excitement about this new product. So don't be shy. Get in touch with your local sales organization that sales Bruker products, as Okan mentioned, that may be distributors. It could be direct. Depends really on the region and country where you're located.
All right. So any last thoughts? Let's start with Okan. Any last thoughts for everybody?
So I love this instrument. I've been waiting for this for a long time, and it's finally here. And I'm excited to use it and share my experience with you. And thank you for being here together with us today. And thank you again for your time. And please get in touch with us to request any kind of information about the system. You may also send samples. We will be here waiting for you. Thank you.
All right. Let's jump over to Michael. Any last thoughts from you?
Yeah, also excited, of course, to see our baby explore the world, so to say. Also excited, hoping customers do like it as much as we do, and yeah, just
All right. Great. And then Peter.
Well, Okan expressed it very well, and there's very little left to add to this. I'm very excited about this new product. Carries a huge name, yeah, and I'm quite sure it will pay back the honor to Sir Isaac Newton by its performance in the field. But so let's get ready to rock it.
All right. And then last but certainly not least, Eckhart. Let's hear yours.
Yeah. I hope we could give you a first taste, first flavor of our new instrument. And I hope we made you curious about it. And as I said, let's put it to the test. Let Okan, let the other people, show it to you, test it, and see if you get as excited as we are about this. So thanks a lot for joining.
Yep. All right. Thank you, everybody. Yeah. And
Thank
we
you.
will be
Thank you.
seeing you later.
Bye.
Thank you.
Bye-bye.
Bye.
Bye.